Welcome, everyone. Connecting your planning to other systems and other departments is a key aspect to your daily work. My name is Sebastian Sieleman, working as a technical product manager for PTV, and I'm happy to guide you today how Visum can support you here. Public transport planning is not a task you do on your own, and most times you don't do it from scratch. Therefore, it's important to interact with your colleagues or partners. That comes with exchanging data of different sources and make use of publicly available data. But transferring data always comes with the risk of loss of information. And therefore, it's important to understand the provided format, know how to interpret the content and integrate it into your model. The goal of today's session is to present what the concepts and workflows for importing public transport data into Visum, covering the two main use cases, building models and updating models.
Importing public transport data into Visum is by purpose a two-step process. Public transport data comes in different formats. Each speaks another language, and we want to include this into Visum. Therefore, we have different specialized importers speaking the language and translate this into a Visum data model. The resulting file contains the original public transport data in a Visum format. But it's this data only, pure public transport data, line routes and timetable information. The goal is to integrate this data into your multimodal transport model. The challenge is that there are no references to match the public transport data and the model data. And this is where the public transport supply importer comes into play. The importer identifies the best fitting stop points and do the map matching for the line routes. Therefore, it's the best tool for both applications. Initial setup your public transport supply in a transport model and update your line routes and timetables in an existing network. Independent of the source of the data is coming from. It might be an already translated by the specific importers into a Visum file, or it might be a Visum file exported from another application, maybe like PTV lines. Today, I will give you a tour showing different workflows for importing PT supply. We will start importing GTFS files into Visum, and I downloaded the file from the internet, but it also might come from your internal operational systems or from your colleagues of a neighboring department. The resulting Visum file will be then integrated into a Visum file representing a multimodal transport model. As a base, I'm using here an OSM network containing the real street network, without all public transport and stops. After integrating the public transport supply, we might hand the model to our colleagues of the network design, and they dump it into PTV lines, designing different scenarios and exporting a PTV Visum file to update your model again with the latest ideas for further assessments. And in the last step, we learn how to export the GTFS data to be used again in the surrounding environments and keeping the original references from the beginning. Let us start with GTFS. You might all know GTFS. It's widely used and a standard format. But it served another purpose in the beginning. It was made for passenger information. Exchanging complete network and timetable information is not the original task. And therefore, the format is very redundant and error-prone. And we try to minimize these effects in our importer. There are, for example, possibilities to fix the deviating coordinates between stops and route courses. And there are ways to aggregate lines, line routes, and time profiles to minimize the redundancy. And this is crucial. Otherwise, you would have to do changes in your travel time, for example, for each trip. Now, let us have a look how this works in Visum. We start with a completely empty Visum file. We go to File, Import GTFS, and we pick the data we want to import. And now we can choose between different calendars. I'm choosing a weekly calendar here, and I'm picking the first day I want to import. And then, yeah, often the stop coordinates does not fit in GTFS to the coordinates of the shape text file. And here you can decide if a new stop should be inserted on the shape of the line course. And for this, you can pick a distance at which this deviation this should happen. There are default settings for transfer times and couplings. And yeah, GTFS stores for each trip time profiles and line routes, and this makes it much almost impossible to edit it afterwards. And so this checkbox can compress all those line routes and time profiles which are identical, and we really suggest to do this. Okay. And then we can set, okay, of course, because we can save those parameters, and with these parameters, you can also do this import via COM. Okay, the import is done. And let us see what's all in there. You see, the line routes are already included. All the line courses are in there. The timetable is in there. All the information about stop points are in there, as well as all those references coming from GTFS, like the stop ID or the stop code, which are stored in GTFS, and the same for the lines, including the line color, and of course also informations coming from GTFS. In the second step, I will show you how to import this data into a Visum model holding the street network. There are some challenges to do so. It is common that the coordinates have been some deviations in locations, which is to be solved by a map matcher. The public transport supply importer helps you here. The importer can identify the best candidates for stop point locations using parameters like snap radius or standard deviation of GTFS coordinates. But for example, if you would simply finding the nearest node, then your line routes might end up looking like this. Therefore, there is more intelligence included into this. The importer not only finds one, but multiple possible candidates. And each holds a probability, which is calculated by different criteria like existing stops, names, resulting route lengths, etc. In the end, the importer imports a line route which connects the best fitting or the most probable candidates. In addition, if you don't import into a PT-free network, you can use existing line routes as a guide for the routing. The importer can be pushed to follow streets which are already used by public transport lines for routing the new ones. To show you this in Visum, I opened a new Visum file which already contains an OSM network with all the network for private transports and for bikes and pedestrians, but without any stops or lines. So there's no public transport in it. I can go to File, Import, and Public Transport Supply from Visum, because the GTFS file we stored before is now a Visum file. I open some predefined parameters here. This is a file where we stored the GTFS information. I don't want to replace or delete active lines in the target networks because we don't have one. In the stop points, we can try to match existing stop points in the target network to the source ones. We don't have this here, but here we choose the number because the number is the key reference, and all new stops which comes in can be compared to the one which are inserted during the import process already. We allow the procedure to add stop points in the target network at existing nodes or links. And if the ID references matches, so if there's a stop point which is already during the process imported, we don't do the geographical search anymore because, but we use this stop point again. Yeah, we have here the stops to reference the stops. We don't need this in here because we don't have stops in here. And here's the tab for routing. We want to consider all possible vertices to do the routing. So it should be using the locations of stop points, nodes, and intermediate points of the original file. For routing, it should consider the length, and there's a detour test done. The snap radius is an important parameter. It defines in which radius candidates should be found. How many candidates should be found, and what is the standard deviation of the GTFS locations coordinates. And here we can do the weighting. So for an initial import, it should be easy to insert a new stop. And for this, we put this to 1. If it's an update, then it should be hard for the procedure to add a new stop point. Then you should reduce this to a lower number in here. There we have to do a mapping between the transport system, so all bus should be used as a bus in here, and we should take care of all those other network objects and how they should be integrated. Okay, and with this we just start the procedure. Okay, and what happened? We now have all stops in here, again with the references, and we have those 34 lines included into the model. You can depict those by maybe showing the line routes in the network, and of course the timetable information. And if we pick here line 3, for instance, you can see its routing is done on the network basis. Based on this model, you can now do multimodal transport planning. For the next step, let us assume you want to hand over the PT supply of this model to your colleagues of the public transport network design as a starting point for their work and ideas. To do this, you can simply save this file and hand it over to them. If your colleagues working with PTV lines, they can simply create a new scenario and drag and drop the stored version file. The PT supply is then imported and ready to edit. I duplicated the scenario and changed the line 3. You can see the difference by comparing those scenarios to the original one. And you see now I'm serving a new stop, serving this small airport. In addition, I decrease the headway to have a higher service rate during 5 to 9 at Monday. This new scenario your colleagues might want to assess in a multimodal transport model, and therefore it should be transferred to PTV Visum. This can be easily be done by hitting Export Supply, and here you can choose between a GTFS file or export it directly as a version file for PTV Visum. When the download is done, you can select here to download the file or start a new export. We download the file and it can be found under your downloads folder. This version file is now the base for your new import in your transport model. It serves as an origin network and should update the existing model. We now open the existing model and go to Import Public Transport Supply from Visum and choose the model from the download area. We can decide if we want to replace and delete the active lines in the target network, and that's exactly what we are wanting to do. And we could decide to just transfer all active vehicle journeys from the source network. This is especially helpful if you have a huge network and know exactly where the changes are done by your colleagues. To ensure that the right stop points are mapped, we add an attribute comparison. Because we have not changed the reference during import, editing, and exported lines, we can use the key attribute number in here. We select the option to add stop points in the target network on nodes and links, and we permit to create new stop points where no candidates are found. This might be the case for the stop point we introduced in lines before. We want to keep the stop and the stop areas as they are in the model. Therefore, we need here as well a matching lines attribute as a reference. And yeah, again, the name works here. For the routing, we will also consider again the stop points, the nodes, and the intermediate points for better routing. We will consider the length and do the detour tests also, and we also keep those settings for the map matching. In the waiting tab now, we have to make sure that as much stop points are reused as possible. Inserting new stop points should be costly. Therefore, we reduce the weight for this new stop point. Due to the high weight of the matching line name, the routing will follow lines with the same line name in Visum and uses the same stop points as this line. And yeah, in the end, we just have to map the transport systems, and then we can hit OK. In the resulting version file, you will now find the new stop point and a rerouted line 3 serving the airport. And of course, in the timetable, the line 3 with the higher surface rate between 5 and 9. So all your data is now transferred from line to Visum. In the last step, I want to export a GTFS file again. Maybe to feed it into an operational third-party system. And for this, it is important to reuse the references from the original GTFS file we initially imported. And as you see, those information survives the whole process of importing and exporting the data. They are still used as user-defined attributes in lines or in stops or line routes as well, and all beginning with GTFS underscore. When I now export GTFS, Visum is searching for exactly those user-defined attributes, and if found all of them, it gives the users the choice to use them as key references for resulting feed. The GTFS feed is stored in your working directory. And if you have a closer look at it, then you may find that the key references in there are the same as in the original feed we imported in the first step.
And this will bring me to the end of today's presentation. Let me shortly summarize what we have seen. First, for many public transport data formats out there, Visum provides specific importer, translating it into a Visum version file. And second, the PT supply importer plays a pivot role to integrate this public transport supply in your existing transport model. Third, this not only works for Visum files from those importers, but for all Visum files, as well from other sources like PTV lines. And fourth, with PTV Visum 2025, it's possible to use the stored reference information from GTFS as keys in the exported feeds. We are aware that transferring data is a key aspect of your daily work. Please contact PTV if you have trouble doing this and think there are still things missing in our software to tackle this challenge. Thanks for watching this presentation and be curious to learn more in the upcoming sessions.